In this lesson, we're going to be writing equations in slope-intercept form. So let me remind you what it takes to have an equation that has slope-intercept form. Slope-intercept form is y equals mx plus b. It's called slope-intercept form because it has a slope and it has an intercept. Okay, so we're going to be writing equations based off of different information that you're going to be given. So in your first section, they're going to give you a slope and a y-intercept. So for example, maybe they'll give you m equals 8 and b equals a negative 7. Again, think about what it takes to have an equation in slope-intercept form. It needs a slope, it needs a y-intercept. They give us all that information, so you're literally just going to plug it right into the equation. Instead of writing m, I'm writing 8. Instead of writing b, I'm writing negative 7. So here you can say, because this is plus, you can say plus a negative 7, or you can say minus 7. They mean the same thing. This bottom equation is the most complete answer. Okay, here's another one. Your slope is 3/4, and your y-intercept is negative 3. Push pause and try that now. Again, when you make this equation, you're going to plug this right into the original equation. Instead of writing m and b, you're writing the number they give you. My m is 3/4, and my y-intercept is negative 3. You can have plus a negative 3 as well. It means the same thing. Okay, so that was the easiest form. They're not always going to give you the slope and the y-intercept straight out. Sometimes you're going to have to find the information. So this section is called Write an equation given a graph. I do want you to make this graph in your notes. I know it's not going to be perfect because you don't have graph paper, but push pause now and make this graph. To write an equation, you need two bits of information. You need slope and you need a y-intercept. Okay, so I need to find those two things. Let's start with slope. You can find slope two different ways with this graph. You can use the equation because they give you two ordered pairs. y2 minus y1 all over x2 minus x1. Or you can look at the graph and use rise over run. And that's what I'm going to do because I think it's easier. It's going to take less time. So for rise over run, you start at one ordered pair and you make your way to the other one, thinking of these as city blocks. You have to go up or down first, and then left to right. So I go up 1, 2, 3, 4, 5. And I run 1, 2, 3. So my slope is 5/3. The other bit of information you're going to need is the y-intercept. The y-intercept is where your line crosses the y-axis. The y-axis, our line crosses right here. On the y-axis, that's negative 2. When you have that information, you can plug it back into the original equation. Instead of m, I put 5/3, and instead of b, I put negative 2. Okay, same thing here. I want you to push pause and copy this graph into your notes. I also want you to try to make the equation on your own. Find slope and then find the y-intercept, put it into an equation. Our next section is write an equation given 2 points. Get two ordered pairs, 0, 2, and 4, negative 1. There are different ways to approach this as well, but the same concept. You need to know slope, you need to know your y-intercept. I can figure out both of those things without graphing. Graphing is an option, but it's going to take longer. So without graphing, I last chapter that our first ordered pairs have subscripts of 1 and our second ordered pair has subscripts of 2, and we plug it right into the formula. y2 minus y1 all over x2 minus x1. Same sign sum. 4 minus 0 is 4. So my slope is negative 3/4. The y-intercept you have to think about. I know I said you don't have to graph this, but I'm going to graph just this one so you understand what's going on. You graph it for your notes as well. On your homework, when you get to this section, you're not going to have to graph it. But I want you to see what's going on. We have an ordered pair, 0, 2. And we have an ordered pair, 4, negative 1. This is what our equation looks like. We already found slope, so I don't need to find it. But think about what your y-intercept is. Your y-intercept is when the line crosses the y-axis. The y-axis right here is at 2. Think of what your ordered pair is. Think about last chapter how we found the y-intercept. When we found the y-intercept of an equation, we put 0 in for x and solve for y. So anytime they give you an ordered pair that has a 0 for x and a number for y, that y is your y-intercept. That number is your y-intercept. Oops, enter. I'm going to explain that one more time. Without even graphing, I know that this is my y-intercept because to find the y-intercept, we learned this last chapter, you plug 0 in for x and solve for y. When x is 0, the other number is your y-intercept. And I proved that to you by graphing. This equation runs through the y-axis at 2. So our y-intercept is 2. So our slope is negative 3/4 and our y-intercept is 2. We use that information to write an equation. And now it's your turn. Again, in this section you don't have to graph. Just use these two ordered pairs to write an equation. 4, 17, and 0, 5. Go ahead and push pause now and try it. Two more sections. This one is write a linear function. Think about what the difference between an equation and a function is. There really is no difference besides the way it's notated. Okay, so this time they give us an f of 0 equals 3 and f of negative 4 equals 11. This is really the same as the last section because technically they gave you two ordered pairs. Think about what this would look like if this were an equation. If this were an equation without f of 0, it would say y equals 3. So this is telling you that we have an ordered pair where the y is 3. And remember last chapter 2 we learned that this really says f of x. So the x is replaced with 0. So this is telling us that the x value is 0. This is also an ordered pair. Remember this really says y equals 11. And this just notates that our x value is negative 4. I'm going to flip these things around. I'm going to put this f of x on top. Here we go. That way it's easier to see when I move this smartboard. Okay. So when they give you two functions, they really give you two ordered pairs. And you're going to write a linear function or write an equation the same way we did in the last section. Find the slope using the slope formula and think about what your y-intercept is. When x is 0, that's your y-intercept. Go ahead and push pause and do that now. Okay, last problem right here. A dance academy charges $20 to use the facility and $25 per hour for instruction. Write an equation that gives a total cost to learn dance at the academy as a function of hours of instruction. Our first step here is to write an equation. Okay, so to find the total cost, that's our equal to. We're going to be adding two things. We have to pay for the facility, which is $20, and we have to pay for instruction, which is a per hour charge. Okay. That $20 for the facility is never going to change. It's a constant. But depending on how many hours we're learning dance, it's going to change. So if we're in dance class for an hour, we're going to be charged $25. If we're in there for 2 hours, we're going to be charged $50. So you see how I'm multiplying it by the number of hours? That's our rate. To find the total cost of how much you're paying for this dance academy, you take the number of hours and multiply it by $25, because that's how much it costs, plus this $20 rental fee for the facility. Your equations are going to look like this as well. You're going to have some rate plus a constant. Okay, next thing. Find the total cost of 2 hours of dance instruction. So they're telling us that we went to dance class for 2 hours. We want to know how much the total cost was. So you would use order of operations. The total cost would be $70. Make sure you write